Friends and colleagues, what are you passionate about? Passionate.
The Passion Show on CFRU 93.3 FM Guelph, Ontario. With Wizard.
I'm a water wizard, Harry.
With
Hello world! You are listening to The Passion Show with Wizard on CFRU 93.3 FM. It's a do-it-together radio show all about passions and the people who have them. My name is Wizard.
And my name is Basil.
Basil. Woo!
Let's go.
Welcome to CFRU, Basil, my dear friend. How are you feeling on this beautiful fall morning?
Thank you so much. I'm feeling amazing. It's so great to be on the University of Guelph campus. It's a beautiful day.
An alumni.
Yeah, we're loving it. Yeah, I'm an alumni.
You went here and learned.
Exactly.
How long ago did you graduate from this school?
I graduated from this school 6 years ago.
Wow. That makes us sound old.
We are.
We are. No, that can't be right. We're not old, we're young, we're babies. I guess I graduated 6 years ago too. But then you do all kinds of stuff in your life.
Yeah. My life is, I guess today's topic will be about chemistry. And my passion is all about chemistry.
We're getting right to it.
Yeah.
Chemistry. What is chemistry?
Chemistry is the study of matter and energy.
All right. That's pretty broad.
It's very broad, but chemistry is a very broad field.
Okay.
Chemistry encapsulates a great number of things.
All right.
It's called the central science for a reason. It
really?
underpins everything in science.
And it does that. I take your word for it.
It's hard to define specifically, but I'm going to share maybe a couple of anecdotes that I find interesting about the development of chemistry.
This is so sick.
Yeah.
This is so sick. Basil, we've been talking about this for a while.
Yeah.
We're getting you in here.
It's a long time coming.
You don't live in Guelph.
No, I don't. I
live far
elsewhere.
away.
Yeah.
You live elsewhere.
I traveled many miles to get here this morning.
Yes. I love how mysterious you are. That's all you need to know about Basil. He lives far away. In a certain place, a location, a town or city.
You could say that.
He works for someone.
I do chemistry for a living. I have the pleasure and the displeasure of mixing chemicals together and making money from that.
You once told me something really beautiful and interesting. Can I share a little anecdote?
Please, I'd love to hear it.
You and I were paddling a canoe together on this sort of beautiful morning after a long and painful adventure. And we were talking about all kinds of stuff. We were talking about art and music and life and chemistry. And I was asking you to explain why you do what you do and how you're so driven to do this difficult thing. And you said to me, every day you get to go to your job and do something that no human being has ever done before. And that has stuck with me significantly. Whenever I talk about you to my people, which I do, not exactly regularly, but not unregularly, it comes up.
For sure.
That is what I say. I say, I have this friend who has done multiple things which are provably firsts.
Definitely.
And I think that's really special.
It's my great pleasure to be able to do that with my life, though they're not necessarily extremely significant firsts.
But they are firsts.
They are certainly firsts.
And that's extremely significant to me.
Yeah, definitely. It's a really fun thing, and it makes life interesting even when certain things are difficult.
Yeah, even when the rest of your life is boring.
Exactly.
At least you're doing something really crazy.
Yeah, it's super fun.
That's how I feel about my job too. I'm like, even if I'm bored, at least I get to climb trees.
Definitely. Yeah, bring some spice into the life.
Exactly. All right, what's your first anecdote, Basil? I feel like we should just, drill right into it.
Sure.
The format has sort of changed over the years of this show. Over the year, I should say. It used to be that the first 20 minutes would be really very lackadaisical.
Okay.
And just random yada yada. And then around 20 or 25 minutes, I would do this whole extended bit. You've listened to the show, so
Definitely.
You may have heard some episodes that are
but
like
I've listened
this.
to more of the early episodes as you're describing.
So there you go. So you might remember some of those moments where I go, there's a little pregnant pause, and then I say something like, well, the people are all asking me to bring up this big question they really want to know. What are you passionate about?
I'm so sorry for jumping the gun on that one.
You're actually totally in line with the sort of meta progression of the Passion Show. The past like dozen or so episodes have been like this. Guests come in, and I feel like it's just an effect of the show being around for longer. People tend to listen to a couple episodes now before they appear on the show because there is such a backlog. And we're getting more into people sit down and are like excited and, you know, driven to just immediately talk about what they're passionate about, which is great.
Totally.
And I'm comfortable to have the show. It's not like I don't dislike the old episodes. Like, I love the old episodes. The show is just however the show wants to be.
Definitely. It evolves.
So, and of course, what doesn't change about the show is that there always has to be some conversation about the show on the show, which I hate. But, you know, whatever.
It's got to happen.
It's got to happen. It's part of the format, I guess. So on that note, let's hear one of these anecdotes, man. Tell me about chemistry.
Well, I don't even know where to begin. I came in today thinking a lot about this one oddity from the 1700s, the late 1700s.
Ooh, so we're like right into the Renaissance.
I think we're a little past the Renaissance at that point.
Okay.
But we are like we're setting the stage in France.
In France, we're like Industrial Revolution, sort of.
I think pre-Industrial Revolution.
Pre-Industrial Revolution.
If my historical timeline is correct.
Okay.
But yeah, so we're like pre-industrialization, post-medieval sort of vibe.
A time of vast change.
Certainly. And yeah, I don't know what the relation is to the French Revolution. Maybe it's a little bit after, but I haven't got a clue actually. But anyways, there is this guy who lives in France at this time named Louis-Claude Cadet de Gassicourt.
Okay, Louis-Claude Cadet de Gassicourt.
Yes.
Is that right?
Yes.
Excellent.
And so this fellow here, he is, I guess he's like kind of adjacent to the nobility in France. He's not necessarily super wealthy or anything like that, but he has enough stature to sort of call himself a scientist and to run some sort of scientific experiments at that time.
He's got access to means.
Exactly.
He's got capital.
Yeah, I think he married into a noble family.
Oh, the dream.
Truly.
Put me in, coach.
Because back in the day, like science used to be something for pretty much exclusively reserved for nobility and people with money. And so he was one of these folks who had access to equipment and access to sort of time to learn the knowledge that would be required to use that equipment.
Makes sense, like thinking about those times. If you can't exactly be doing these long-term studies if you need to work at the whale oil factory to like feed your kids.
Yeah, if you're away at sea for a full year, you're not doing much science.
Exactly. You forget, you come back and you're like, I forget. I forget all the physics.
Exactly.
But not this guy.
Notably, chemistry at this time is not very well developed. Okay. We don't have the periodic table as we currently understand it. We have some elements that are pure and maybe some trends in how we understand how these elements interact, but we really aren't like at a mature periodic table yet, which is for the non-chemist listeners, a periodic table is basically a way of grouping elements into sort of similar groupings by some mathematical means that represents their actual like structure. So that all had to be developed, and the most commonly cited first periodic table came about in the mid 1850s, I think, by a fellow named Dmitry Mendeleev.
Dmitry Mendeleev.
Yes, sir.
Comes up with the first. I would like to see an image of that at some point.
Yeah,
the
definitely.
First periodic table.
It doesn't really look that similar to the current periodic table that we're looking at. It's missing a lot of elements.
Yeah.
And the sort of interesting thing about the early periodic tables. So Mendeleev's periodic table isn't actually the first one of its kind, but it was I don't know why it's necessarily considered to be the first, but it is the most important early periodic table. I think specifically because he predicted the existence of elements that hadn't yet been discovered.
Okay, and that's an important part of periodic tabling.
Exactly. Like he made a hypothesis, like somewhere in this like organization of elements, we're gonna.
There should be something here. There should be more noble gases or whatever.
Yeah, definitely. And the noble gases are a whole other topic because they actually weren't discovered until way later.
Whoa.
Because the noble gases basically don't do anything. They're completely unreactive, and they compose a relatively small constituent of the air. So actually obtaining them in pure form is hard in the first place, and then to prove that they're an actual chemical entity is also difficult because they're so unreactive. And a lot of people didn't believe the initial inventor of or discoverer of the noble gases. Yeah,
that is so interesting. That's funny. That reminds me of this thing I've been telling kids recently at outdoor school. Of course, this is always...
We got to come back
we got to loop around. This is what the show's all about.
Yes, sir.
Loops and strange loops. I've been taking kids for nature walks. Obviously, it's the start of fall, and it's such a good time to go for a nature walk because you can observe the forest as it is in front of you and see it in its static state, right? It's like it's fall, but you don't really know it's fall. And I tell this to kids. I'm like, you see how there are leaves in the tree? And you see how there are leaves on the ground. Now, you're just how do you know that those leaves haven't always been on the ground? How do we know that the forest doesn't just always look at like this? Well, it's because we remember that the leaves used to be on the trees in the summer. And how are we going to know what fall is? How are we going to know what winter is? How do we know what happens in fall if we don't remember what we see right now and compare it to what this forest looks like in 3 months from now?
Exactly.
So I take them on these walks. I'm like, memorize everything you see. You're going to do science by comparing these things. We're going to take you on another walk through the same forest, this exact same hike in 2 months. And it's going to look completely different. And that's how you'll know that's how you'll really, truly, actually understand fall on like a true basis.
That's really great.
So you just reminded, I guess it's kind of like science.
Yeah, it's like observation, and then if you write it down, it's science. If you write down any observations about any sort of phenomenon, that's science.
A kid had a great moment 2 days ago on Wednesday. A kid was like, there used to be a mushroom there. And I was like, yeah, I remember there did used to be a mushroom right there. What do you think happened to it? And all the kids were like, hypothesizing.
Nice.
And like, maybe a squirrel ate it. And I was like, yeah, that could be so. That could easily be so. What else could happen to it? And they're like, maybe it fell off and decomposed. I'm like, fell off? What do you mean fell off? And they're like, maybe something hit it off. Maybe this, maybe that. Yes, take some notes.
Definitely.
It's like, how do we know? Maybe let's investigate the area. Maybe let's set up a trail cam.
Find some evidence.
God, I'm excited just because some kid noticed a mushroom was gone.
But it's a great example of like the human creative spirit and the scientific spirit.
Yeah, right? And kids want to know.
Yeah, exactly.
We got to foster that. We got to maintain that desire.
Exactly.
So, periodic table. Let's loop back into that. Enough of outdoor school anecdotes. I've got a bazillion of them. I'm sure I'll be saying the same stuff in 10 episodes from now. But you won't be here, Basil. So, were we talking about the periodic table? I feel like that was a sidebar. We've just gone to sidebar on a sidebar.
I think we're 4 sidebars deep now, probably.
Let's run it back. We'll run it back to the 1700s.
Louis-Claude Cadet.
Yeah.
So, this fellow here is one of my favorite historical curiosities, because I don't necessarily know if his discovery is that it is meaningful, but it's not that meaningful. And I find it interesting because of how absurd it is. And I will explain.
Ooh, this is exciting.
So, Mr. Cadet had his experiments led to him mixing arsenic oxide with potassium acetate at some point. So potassium acetate is a pretty common chemical. You can make it very easily, and it's not dangerous at all. Arsenic oxide is a very hazardous chemical. It is deeply poisonous, and it is often found in a very fine powder. And it's difficult to produce it without having it aerosolize and to cause it to be dangerous to your health.
It's like what happened when they put arsenic in paint, right? As it aerosolized in the heat.
Yeah. There's the famous paint Paris green, I think.
Yeah,
that
exactly.
Had arsenic in it. Supposedly, maybe killed Napoleon, but that's
what they say.
That's archaic.
I've read a little bit about this, where it's like no one actually knows.
Yeah,
It's spooky. It's just like,
but
you can get killed by all kinds of stuff.
Exactly. And arsenic compounds are famously toxic and not really something that you want to be around. But in Monsieur Cadet's experiments, he ended up mixing these two things together.
Okay.
And what formed in his reaction setup was a liquid. He formed a red fuming liquid.
Okay, that sounds scary.
And there's a Wikipedia page and a series of articles that discuss this liquid. It's called Cadet's Fuming Liquid. And that's what I'm here to discuss.
Cadet's Fuming Liquid.
This is purely a curiosity, generally speaking, but I find it to be fascinating for a number of reasons. So
you have me hook, line, and sinker.
Cadet's Fuming Liquid can be distilled. Back in the late 1700s, they had the technology to do distillations. Alchemists had been doing distillations for many years before that.
That's amazing.
With the advent of, in many people's opinion, the advent of hard liquor also led to the development of more advanced chemistry because distillation equipment became more widespread and the knowledge of how to use distillation equipment became more widespread also. And so basically Cadet took this red liquid that he had prepared, his fuming red liquid, and he was able to distill it, and he was able to distill it into two components.
Okay.
One of them is, I believe, is still a red liquid, and then one of them is a white liquid. And as far as I am aware, both of them fume into air.
I was going to ask.
It is very notable that this, as far as I can tell based on my internet research, this red fuming liquid has not been prepared since relative antiquity.
Okay.
I believe the last person, nobody has prepared it and talked about it in the internet
published
age.
on it or...
Yeah.
Okay.
Which makes it even more interesting because I really want to see photographic evidence of the red liquid.
Yeah, I want to see this red liquid. I want to see it fume.
Exactly. So the significance of this red liquid, just to make the viewers clear on what it is.
Viewers?
The listeners. I apologize to the dear listeners in their car.
Yeah, in their car driving around Hong Kong, beep, beep, 9:16. It's almost December. Time to bundle up.
Oh, man. It's getting cold out there.
It's the 21st when they're hearing this. November 21st. Can you believe that?
Wow.
Sheesh.
It gets late in the year fast.
Yeah, right? Especially when you're recording into weeks, if not months, into the future. How's it going in November, listeners? Here we are in relatively warm early October. Get wrecked.
Get wrecked.
Anyways, so we want the listeners to be able to picture this easily in their heads.
Yeah, so the significance of this liquid is that it is the first organometallic compound.
Organometallic. Incredible.
So an organometallic compound is a compound that has a bond between a metal and a carbon.
Okay, I can understand the significance of this. And also that's spooky.
Yeah, so organometallic compounds have been prepared much past Cadet's time and have found relative great usefulness actually in modern chemistry. So, for instance, I use organometallic compounds all the time, and they're very useful in the work that I do. But
making chemicals of some kind.
Exactly. And so it's a very significant thing to have made the first organometallic compound because of its legacy in science. We wouldn't have a lot of the developments in medicine that we currently have without the ability to use organometallic compounds because they're so good at making bonds between carbons and other carbons. But we won't get too into the weeds on the chemistry.
This makes sense to me sort of on like a surface level, where from what I understand about like medicine and human body interactions with chemicals, you would want something like that to deliver different kinds of compounds into our system. Is that like a decent explanation of it?
Well, actually, organometallic compounds tend to be relatively unstable.
Okay.
So organometallic compounds, basically the reason why Cadet's fuming liquid fumes is because, as far as I am aware, it's decomposing because of the moisture and the oxygen in the air. So organometallic compounds are very sensitive to the components of our atmosphere, such as water and oxygen, particularly water. And
we're full of that stuff.
We're full of that stuff. And a lot of people don't know how full the air is of water. The air has so much water in it. And whenever you're working with organometallic compounds, you need to take great care to exclude water from the reaction. Otherwise, you're going to cause yourself a headache. And so they're not so much a good thing for delivering a drug into a body as they are as a useful tool for preparing a drug molecule.
I see.
So back in the research and development of these drugs, these organometallic compounds are super useful, but not a lot of people are like, vibing with the organometallics. But, it's a major component of the pharmaceutical industry.
Early stepping stone where it's like it's like finding a puzzle piece and you don't know where it goes yet. But it's like, this is going to be an important puzzle piece.
Yeah, exactly. It'll react with like certain things and it makes useful bonds.
Okay.
Yeah.
This is awesome. This is I'm so happy right now. I'm on cloud 9.
I'm so glad.
I love being told about stuff. Because, I think part of the reason I'm capable of doing this show well is because I've made it a point of pride in my life since high school, I would say, to try and become, relatively decently aware of a wide breadth of studies. And chemistry just isn't one of them.
That's so reasonable. It's not one of them for most people.
And so I'm sitting here, my goofy butt barely got through grade 11 chemistry. I had to cram with friends of the show, Logan and Evan.
We love those guys.
All day long. We do love those guys. For a whole entire day, I remember vividly horrible to just like eke out like a 70 in the class just by the skin of my...
Totally.
By the hairs on my chinny chin chin. And so I'm just sitting here hearing about this fuming red liquid. Also, this is one of the earliest moments in an episode I've ever been 100% sure about what it's going to be called on the feed. This episode is called Fuming Red Liquid.
This is awesome.
With Basil. All right, tell me more about the fuming red liquid.
So the thing... I learned about this liquid maybe around a year ago. Okay. And when I first learned about it, I could not stop myself from reading everything that I could find that was published about it. And I could not stop myself from laughing so hard about the nature of this compound because as a chemist, it is so comically horrendous. It is a horrible, terrible, incredibly terrible compound. It is, as far as organometallics go, about as bad as it can possibly get, with a big asterisk beside like methyl mercury and like certain methyl stannanes. But it is
methyl mercury. There's a compound called methyl mercury.
Certainly is.
The brain destroyer.
Yeah. Do you know about the incident with Karen Waterhan?
I think I've watched a YouTube video about this.
Yeah, it's a really tragic and like famous story where a chemistry professor was working with this compound methyl mercury and dropped a single drop of it onto their glove and tragically passed away a while later due to the effects of that.
I watched a Chubby Emu video about that. You know that channel?
I don't know that channel.
He's a biochemist, pharmaceutical doctor guy from New York State who runs this YouTube channel for fun where he sort of analyzes case studies. It's brilliant. And I started watching his channel probably a good decade ago because he used to make Let's Plays of Nuclear Throne, which is a video game that I am really into.
That's so cool.
And then he was like, I'm going to transition my whole channel into doing case studies on like chemical interactions and human bodies. And he'll have videos like, someone ate an old sushi from the gas station. This is what happened to their liver.
Oh, interesting. I think I've seen those like thumbnails before.
Those are parodies of his style, and he's brilliant. And he did a video about that case study, and it really stuck with me because it broke my heart.
It is a really tragic story.
Yeah. And usually when he gets to the end of the case study, he does not talk about the reality. He doesn't talk about the actual case, but in that one he did, and I went and looked it up. This was a long time ago. That this video came out, so I don't remember much about it. But yeah, methyl mercury is the most comedically, psychotically evil sounding chemical
it is
imaginable.
a terrible chemical. I would not want to work with it. I would probably refuse to work with it.
Yeah, no methyl mercury for us.
In fact, I would certainly refuse to work with it.
But red fuming liquid, on the other hand.
As much as I would love to prepare a sample of Cadet's fuming liquid, I would also refuse to prepare a sample of Cadet's fuming liquid. Truly, it is a horrible compound.
Okay.
And I will expand on that.
Yeah, tell me more.
The most significant or striking element of Cadet's fuming liquid that you will notice upon preparing it
Other than the fumingness and the redness.
Well, those two are really nice. We love to see the fumingness and the redness.
Yeah.
But the sort of most significant horrible element of it is the smell.
Okay.
It smells... I mean, nobody alive, as far as I can tell, has smelled it.
Whoa.
But the accounts in the literature say that it has a noxious garlic-like smell.
Whoa. That makes sense because of the one of the things in there smells like garlic, right?
What
was the chemical? Arsenic. Doesn't arsenic smell like garlic?
Probably. I definitely don't know. Also, arsenic comes in so many different forms, and,
That's right.
and generally, like, some things with an element will smell sometimes, and then some other compounds will not smell at all or smell completely different in a weird way.
My head always goes to. I'm learning something about myself in this episode. I always try and like rationalize things or like make patterns, and something that chemistry is a teacher of, and this is probably why I bounced off it so hard in grade 11. Chemistry just smacks that down. It's like, nope, don't generalize that. You can't. There's just too much stuff going on. The world is too big.
Yeah, definitely. It's a messy field. It's hard it's hard to know everything in it.
That's why I'm so obviously like titillated and excited by this conversation.
I'm so glad.
Okay, so you noticed you made your fuming red liquid stinky.
It's absolutely terrible smelling, according to all reports that have prepared it. And it is truly very, very toxic.
Okay.
And of course, the toxicity of this compound couldn't have been directly known by Monsieur Cadet. But he prepared it nonetheless, and ostensibly prepared it a couple times and showed it to people because it's the main thing that he is known for today.
Wow.
It is pretty much the only thing that I can find that he is known for, is preparing a fuming liquid in 1793.
So sick.
It's so awesome.
He found out quickly that it was toxic when he started using it to season his baguettes.
Well, we'll get there in a minute.
Okay, perfect.
The liquid is truly a terrible thing. It is not something that you would want to prepare.
Not good stuff.
Basically, the thing that I find so interesting about the liquid is that at the time of the liquid's preparation, it was sort of noted to be somewhat noteworthy because it fumed and had these strange characteristics of extremely foul odor. But the people who were working with that liquid at the time had no meaningful concept of chemical bonding. So they would not really have been capable of understanding what it is that they prepared. And so to me, when I think about this guy in France in the late 1700s preparing a horribly stinky, horribly toxic liquid that he could not possibly be equipped to understand in any meaningful way, and somehow being well known for it 200 and whatever years later, is just so funny and so awesome.
That's great.
And just a wonderful chemical oddity in the history of chemistry.
That is such a phenomenal anecdote.
Definitely. Now, I think that the main reason why we know about Cadet's fuming liquid today so much is because of the work of our new main character of this anecdote.
Yes.
Which is a fellow named Robert Bunsen.
Bunsen. I know that name.
Yeah, what do you know him for?
He made a burner.
He certainly did.
Yes.
And arguably...
Robert Bunsen. Come on.
Robert Bunsen...
I love chemistry.
We love chemistry in this radio station.
Yes. CFRU endorses chemistry. You heard it here first, folks.
Robert Bunsen picked up where Cadet left off in the mid-1800s.
Oh, yeah?
So a significant amount of time has passed.
Yeah.
But Bunsen is a character. He can only be described as a character.
Okay.
And we'll get into that.
Perfect.
But Robert Bunsen is a legend of chemistry.
Okay.
And anybody who you would tell his name to off the street would have the same reaction as you. Oh, this fellow
that guy from
invented
Burner.
the Bunsen burner.
Yeah.
And it can be said with great confidence that the Bunsen burner is one of the least significant things that he ever did,
Whoa.
which is pretty awesome.
Yeah. Wow. That's crazy.
Yeah,
You would certainly think that the Bunsen burner, because that's a significant item.
definitely.
Okay. So what
but
else did this guy do?
So the Bunsen burner is a component of a setup for doing spectroscopy on chemical elements.
Spectroscopy.
Spectroscopy.
Tell me about that.
Spectroscopy is when we're talking about atomic emission spectrum, it's a way of observing wavelengths that chemical elements emit in a flame, basically. So you'll have an element, you'll burn it in a flame, and it will emit a wavelength of a particular wavelength. It'll actually be several wavelengths, and you can use a spectroscoper. I don't know how to say that, but you can
Something
use
to
the
that
equipment
effect.
that Robert Bunsen invented along with his pal Kirchhoff
Okay.
to observe the spectral lines of a chemical element. So every chemical element will have its own distinct and unique set of spectral lines. And basically you can use the spectroscopy method to definitively tell that something is a particular chemical element or is not a particular chemical element or is a brand new chemical element.
Okay.
And this is an extraordinarily important invention in the history of chemistry for numerous reasons.
Noble gases, perhaps?
The noble gases were first proven to be distinct entities because of this spectroscopy.
Yes.
Though I think the experimental setup might have been a little bit different because they don't burn. Maybe they're just shining. I don't know how the experiment would have worked, but they used spectroscopy to prove the existence of the noble gases. As well as the existence of every other element.
They don't burn. Of course they don't burn. Stinking. They don't do nothing.
Exactly. But so Robert Bunsen is really an icon of chemistry. He's working in the mid-1800s in Germany. He was famous during his lifetime. He was a public figure during his lifetime.
Cool.
Which is
Wouldn't
really
have guessed
cool.
that. He's like doing speeches and stuff, or people just know about him?
He's just well known in Marburg and Heidelberg.
Gotcha. In the way that like people know certain like scientists today.
Yeah,
It's just like,
kind
that's
of.
a smart guy. Someone's just smart enough.
Yeah, I think so. But also Robert Bunsen was a really, I mean, all of this is obviously not from living people and we can't really corroborate any real factual evidence about him. But he was really dedicated to experiment over theory. A lot of the time in the early development of chemistry, people, and granted Robert Bunsen's a little bit later in the chemical lineage than some of these people who were really talking about theory over experiment. But a really big through line in the early development of chemistry is the emphasis on doing experiments carefully and taking readings and using the evidence that you collect from your experiments in order to inform you about the world around you. Because a lot of the earlier people who worked with matter and energy, who we would refer to as alchemists, were basically formulating theories about what their stuff was, but not actually using the scientific method to create meaningful data about their experiments.
Playing a little fast and loose.
Exactly, yeah. And so Robert Bunsen basically did not really talk that much about the theory of what he was doing. He famously spent a lot of his time in the lab, and he was famously. He had one fun thing about Robert Bunsen is that he had very large thumbs. Okay. And he would use his thumbs to cover the openings of his experimental apparatus to make sure that gas wouldn't leak out of them. And he had giant thumbs. And he would sort of screen the chemists that he would work with based on the sizes of their thumbs. Because a chemist with large thumbs is able to handle the apparatus and thus makes them a useful person to have in the lab.
That's crazy. That's a great... Okay, that's so interesting.
the other interesting thing is that Robert Bunsen, he was a person of stature in his society, and so he would often he had a residence that was appointed to him by the university. He basically built out the chemistry department, and he would sometimes be invited out to events, and he would draw great attention to his relatively disfigured thumbs by trying to hide them from the ladies at the events that he would go to.
Awesome.
So you're very obviously drawing attention to them by trying to hide them so well, and so that was a very interesting thing. Robert Bunsen is famously, there's one more anecdote about him with the ladies that is quite interesting.
Perfect. Yes, more.
So he had one time asked for a girl's hand in marriage.
As we all sometimes do.
It happens, And so he had courted this girl, asked for her hand, and then he learned about Cadet's Fuming Liquid.
Yes! The Fuming Liquid.
And he became so enthralled in his organoarsenic experimentation that he disappeared for a number of weeks.
Oh, man. No, not like this.
And possibly due to a combination of arsenic poisoning and general forgetfulness, he had forgotten whether or not he had asked for the girl's hand in marriage. Okay. And so he came back a few weeks later after having no contact with her and asked for her hand in marriage a second time, just to be sure. And sadly, it did not work out for him.
Oh my God.
It's a pretty relatable moment when you're so encapsulated by your organoarsenic chemistry.
Like, did I ask that my girlfriend to marry me? I forget. I've been busy on my grind. Exactly. It's like when I go into the studio to record a few dozen passion shows.
Everything becomes tunnel vision.
Did I forget? Might as well just run it back. Like, what's the harm in another? Maybe she'll think it's cute.
Exactly. But unfortunately, it didn't seem that she found it cute, and he was a bachelor his whole life, as far as I'm aware.
Bunsen,
my man. He's also the first person to invent cesium and rubidium, which are two very interesting chemical elements.
Oh, tell me one interesting thing about each.
Well, rubidium is less of an interesting element than cesium.
All right, tell me about cesium
then. Cesium on the periodic table sits right underneath rubidium.
Okay.
It is a very heavy group in the sort of alkali metal group in the periodic table. And these are the most reactive metals in the periodic table.
That's
cesium
why they're
is
like batteries and stuff.
There probably are batteries with alkali metals, but none are springing to mind.
Interesting. Okay.
But you know how sodium metal? Have you ever seen videos of sodium metal being thrown into the water, for instance?
And it goes like,
yeah. Is that? Or if you throw enough of it in, it will go boom.
Okay, cool.
And so sodium.
I think I have seen videos of that.
Yeah, sodium is extremely reactive, and it's at the top of the alkali metals period. And as you go down, the elements become increasingly more reactive.
Oh, wow.
Now, actually, I'm not entirely certain if Bunsen would have isolated cesium in its metallic form. Something tells me he may not have, but he was the first person to observe cesium, probably in a salt form, but I'm not an expert on that. But cesium as a metal is the most reactive of this type of compound. That is like actually able to be handled, as far as I know.
Okay.
And so if you take a sample of cesium, it will react aggressively with pretty much anything. Okay. It reacts so aggressively with atmospheric water. It's essentially completely unhandleable unless you have a professional setup to prepare and distill it.
Yeah. You know what this stuff sounds like? Me before I have my coffee in the morning. Sounds like my wife before she had a coffee in the morning.
Yeah.
Reacting aggressively with everything. Give me my cup of joe. That's a dumb thing.
We like that. But yeah, he's a person of extreme interest, and he also seemed to be quite the character in life. And I really appreciate that about Mr. Bunsen.
Mr. Bunsen was dedicated to his craft.
Yes.
I love people like that.
And he was dedicated to organo-arsenic chemistry, just like Louis-Claude Cadet de Gassicourt. But Robert Bunsen approached his studies in a little bit more of a rigorous way, and was actually able to characterize the compounds in Cadet's Fuming Liquid, and I find that to be quite a nice thing. You know, Robert Bunsen almost died by giving himself arsenic poisoning, probably on multiple occasions, but one time in particular, very much had a massive exposure to arsenic when I think his fuming liquid exploded all over him. I think also it might have put out one of his eyes a little bit. Okay. And on a separate incident, the other eye almost came out when he was working with platinum compounds that had hydrogen around them, which is a very explosive mixture.
Good to know.
And so, you know, the lifespan of a chemist back in the day was probably not very high.
No.
They are really just out there doing all of the things that you're really not supposed to. But Bunsen beat the odds. He died at the ripe old age of 88 years old.
Wow.
And
that's old today.
Yes. So he
him.
is one of my favorite historical chemists.
Roberts live forever.
Live forever.
My dad, our friend. Big dogs die last.
Big dogs die last.
You got this, Rob. You're going to live just like Mr. Bunsen. I'm sure he's listening to this.
Absolutely.
Well, I hope you live as long as Robert Bunsen.
I would love to. May we all live to the ripe old age of 88,
and
inshallah.
Even beyond. Truly. Man, this is the best. This is the best episode ever.
I love that.
I'm in hog heaven right now. Thank God the Passion Show lasted long enough to get Basil on the show.
We love that.
My goat, the chemist, the legend. You've talked about a lot of explosives. Now, what about the other side of that coin? What's the opposite of an explosive?
That's a great question.
A drug.
It is often said that chemists get into chemistry because they have some interest in explosives or drugs. And that does seem to be generally true, I suppose.
That's beautiful.
But yeah, I wouldn't say a drug is the opposite of an explosive, but it is an interesting friend to a chemist, I suppose.
Because a drug can go in you and an explosive can't. Or perhaps shouldn't.
It probably shouldn't. It probably can.
Yeah, I suppose it can. There's nothing technically stopping me from eating an explosive.
Exactly. But yeah, drugs are a really interesting part of the development of modern medicine, really. And it's my particular sort of professional interest. Is the chemistry of drugs and drug-like compounds.
Drug-like compounds. That's amazing. No officer. They're just drug-like compounds.
Well, just to be clear, I'm not talking about the illegal ones.
Okay. Talking about the good ones.
Well, yeah.
Officer, I swear. They're just drug-like. That's funny.
Yeah, a big element of the development of a new medication is drug likeness. Often we're looking at so many of the properties that a molecule that we might be interested in has, just because most molecules are not really fit to be drugs, and there is a sort of ineffable drug likeness that a pharmaceutical has to have in order to be able to affect its target in a meaningful way that improves human health.
That's so fascinating to me. The whole, a human body is just so chemically complicated.
Absolutely.
Ungodly, especially, even just one, and I suppose this is conjecture. You can tell me if I'm right or not. But, just one human body as a single study is complicated. Then you also have to think about the variance.
Absolutely.
That in a population.
Yeah. It makes doing clinical trials really challenging, honestly.
I really respect a lot of math must go into that, eh?
Definitely. It's a lot of statistics and population medicine type of equations.
Man, there's another world where I got into that.
Yeah, I mean, it's not too late.
I do love numbers. And I guess it's not too late, huh? I can go back to school and become a hyper specialized, like population drug studies guy.
People have that job.
Yeah, I bet you they do. I could work for Apotex or whatever.
Apotex is a whole other topic.
Yeah.
I don't think they're doing population medicine.
No. I don't know anything about Apotex.
They manufacture generic versions of drugs in Canada.
Yeah, that's how my dad's a pharmacist, folks.
Oh, cool. He gets from Apotex?
Yeah.
That's cool.
And like, I don't know, there are other companies, but for whatever reason, I always just remember Apotex, probably because it starts with A.
Yeah,
so it's always at the start of lists.
That makes a lot of sense.
And
it's a real classic.
The other company I know, I don't sure. What does this company do? McKesson.
Never heard of that in my life.
Interesting. Okay.
But I don't know very much about like pharmaceuticals from like the pharmacy.
Yeah, it's a different world. I guess it's a big world.
Yeah, definitely.
Of drugs.
But I can tell you it's not one of the major pharma companies, probably.
McKesson, the reason I know McKesson is because they manufacture these purple tote boxes that were just like ever present in my life as a child. Because everything, they're like hard shell plastic with like folding lids.
Cool.
Tote boxes like about 2 foot by 1 foot by 1 foot.
Yeah.
And they're just absolutely everywhere. In my home and my dad's pharmacy, there are like 3 McKessons under my bed.
Fascinating.
With just like stuff in them.
It's just a ubiquitous item for you.
Just a ubiquitous item. And it's very specific, I think, to my life.
That's so awesome.
And I suppose the other pharmacy brats out there, us kids who live a hard knock life of daddy pharmacist. No, it's a great life. I love my dad and I love prescriptions and meds and stuff. Shouts to Apotex.
It's a cool world.
It's a cool world. That guy knows a lot of stuff. He's going to be on the show one day.
Oh, you should totally bring him on.
Yeah. Wouldn't that be sick? We could do a sequel to this episode.
Definitely.
But just about generic medications and interactions and stuff.
That would be a really cool episode.
I'll print out a list of like drugs and say, what's the interaction between this and this? And you can tell me, and I'll be like, interesting. Okay, now what about this and this?
It sounds like a nightmare to me.
It'll be an absolute snooze fest. I'll have a great time. I get so tickled when I hear him talk about this stuff because most of what I hear him talk about is football.
Right.
And, whatever, at-home stuff. So whenever I hear my dad be a genius, I'm always like, oh, my God.
This guy.
That's right. You're also a genius. You're not just my dad.
It is an awesome feeling to have.
It's true. And I'm experiencing that with you. Well, I experience that with you all the time.
Far from.
I'm like, man, Tim knows his stuff. You got any more anecdotes for me? We're almost out of time. We've got 10 minutes. We've got less than 10 minutes.
Well, I can share a sort of fun one that is that really I find interesting for a similar reason to the Fuming Liquid, I suppose. There is this group of metals called the platinum group metals.
Platinum group.
Yeah.
That's a sexy name for a group.
Absolutely.
We should call our friends the
platinum group metals.
Yeah, what's up, platinum group?
Well, and the nice thing about the platinum group is there's a bunch of them, so you could reasonably call all your friends by a different platinum group metal.
You, me.
You got rhodium, you got osmium, you got all of them.
Robium, we got logium.
Logium.
We got gregium.
That's so good.
At all. All right, tell me about the platinum group metals.
So the platinum group metals are kind of like the noble gases of the metals. They're not very reactive, but their reactivity is possible, and it is generally useful when you get the platinum group metals to engage in some sort of reaction. So the platinum group metals tend to do catalytic reactions. So for instance, they're used in your car's exhaust to scrub all of the nasty fumes.
The catalytic converter.
Catalytic converter. So the catalytic converter is full of these platinum group metals.
That's right. That's why they're so expensive. That's why people teef them.
Yeah, that's why you want to get one of those.
Yeah, it's a platinum in there.
It's a useful material. It's also used like industrially for various applications. But in general, the platinum group metals are really, really useful. And unfortunately, they're hard to get. And there is a great human cost in obtaining them. Mining of metals in general is very terrible for the people who have to do them. And the Platinum group metals are no exception. They're really very hard to obtain, especially because their abundance in the Earth's crust is very low. And even where they are relatively abundant, they require great effort to extract them and to
separate.
refine them.
Gotcha.
Because they'll often come as a mixture of the different chemical elements. So
a lot of distilling. Distilling is a real thing. Separating. That seems like a lot of what chemists do.
Chemistry is massively about separating things. Not in the case of the platinum group metals, it's generally, well, I would say it's definitely not about distilling. It's about finding different chemical reactivities in order to separate one metal from another. So maybe one metal in its salt form will react a certain way that is different from another metal. And so if you have those two metals in solution together, you might be able to precipitate one of them and leave the other one in the solution so that you can just filter off the desired metal, and then you've done a purification, and now you have pure metal.
Wow. Well, okay. The one thing that's been on my mind, what is the definition of distilling? Like, what is distilling chemically? Because I know, like, in the vague and general English sense, but what is distilling?
Yeah, so distilling is taking a volatile compound. So when I say volatile, I mean that it is able to evaporate. So you can take any sort of volatile compound. Let's use ethanol as an example because it's the most commonly distilled thing that I know of. So if you are distilling ethanol, you're basically going to heat that ethanol along with whatever other stuff you're trying to separate the ethanol from. So you'll have a big flask that contains some ethanol and some other stuff that you don't want. And what you'll do is you'll heat that flask, and you'll be able to make the ethanol go into the gas phase. And so you'll go from a liquid form of ethanol to gas ethanol, and it will travel up some sort of distillation column. Generally, if you're doing it on an industrial scale, you'll have some sort of fractionating column that allows you to separate the ethanol in the gas phase from other volatile compounds that have similar boiling points to that ethanol. So really, when you're dealing with distillation, you're trying to separate compounds based on their boiling point.
Gotcha. So it's like a very specific meaning, and a specific thing of what distillation is.
So like in one sentence, distillation is evaporating a compound and cooling it down so that it turns into a liquid again and collecting that liquid.
Gotcha.
But as a sort of useful thing to do, you'll tend to use distillation as a means of purifying something or separating it from other stuff in your flask.
Okay.
So if you are trying to separate the thing in your flask with the lowest boiling point, that's a good application for distillation because the first thing that's going to go into gas from your liquid reaction is going to first travel up that fractionating column, and it's going to condense on a condenser that you have, and you're going to be able to collect that pure liquid on the other side of your distillation setup.
I've seen this in Nile Red videos.
Yeah.
Okay, so back to the
back to those
shout out to
platinum
Nile
group
Red, by the way. Back to the platinum, where we got like 3 minutes basically until gratitude time.
Perfect.
So get me this platinum group anecdote, make me giggle, and then we'll pull a bow tie on this thing.
Lovely. Well, we're lucky that it's not a very long anecdote.
Perfect.
So there are numerous platinum group metals, and there is this fellow in, I think it's 1803, named William Wollaston.
William Wallace, just like the Braveheart. Very good. Okay, William Wollaston.
Yeah, William Wollaston, and he's living in England, I believe.
Okay.
And he has a sample of ores that contain platinum and some other stuff. And he uses chemical means by like working with. He dissolves up these platinum compounds. The platinum group metals, and then uses chemical means to separate them from one another, just like I described a few minutes ago, by taking advantage of their different reactivities and precipitating some out in favor of others. And so he obtains this material from his studies that was previously unknown to science. They already knew about platinum at that time, but they did not know about this chemical called palladium.
Okay.
Palladium is maybe not very well known to most people, but it is, as far as I know, the major component of catalytic converters. I think that's its main industrial application.
Okay.
But as a synthetic chemist, palladium is an element of great stature. It is the element that is that makes modern organic chemistry work generally.
Whoa. Okay.
Palladium is incredibly good at allowing certain types of carbon-carbon bonds to form, which may not mean very much to most people, but it's an extremely useful type of reaction. And it's very difficult to do by means that don't involve palladium. Now, this has changed in recent years because of advances in research to some extent, but palladium is really like the king of making this type of bond, and it is incredibly widespread across the pharmaceutical industry. And it is a molecule that's very near and dear to my heart, and it's a metal that is very near and dear to many chemists' hearts.
Okay.
And in 1803,
So
William
your
Wollaston...
favorite chemist's favorite chemical.
Yes, we all love palladium.
Okay, sweet.
In 1803, William Wollaston obtains a sample of palladium. And instead of letting the scientific community know about it, he sits on it for 2 years.
Okay.
Until he gets called out. Because he, instead of publishing it, as I say, he sells it in his store. He has a little curiosity shop, and he sells this metal called palladium. And he was accused by another scientist of just having an alloy, which is a mixture of metals, of platinum and mercury. And he was like, nope. And then he was like, I'm going to publish. And that's the story of the discovery of palladium, one of the most industrially useful materials out there.
And it comes from a call-out post.
Yeah, pretty much.
That's crazy.
And this guy's like laziness in the sense of like he figured it out that it's like a real chemical element and just kind of sat on it and like sold it in his curiosity shop.
Wow. What a legend.
What a legend. Absolute boss move.
Know what else is a boss move?
What's that?
It's you coming all the way to Guelph, Ontario to be on The Passion Show.
It's been my great pleasure to be on The Passion Show.
It's been my great pleasure to finally have you on The Passion Show. Thank you so much. Let's say some gratitudes and wrap this puppy dog up, why don't we?
Absolutely.
I'm feeling grateful today. I'm feeling grateful for the wind. I'm feeling grateful for the clouds. I'm feeling grateful for my friends. I'm feeling grateful for Logan's Cottage. I'm grateful for the Aramosa River. I'm grateful to you. Grateful to chemicals like palladium and mercury and methyl mercuries and
all of our favorites.
All of our favorite and the red fuming liquids of the world. I'm complete. What are you grateful for?
I'm grateful for the chance to have the sun come up in Guelph, Ontario, and it to be an absolutely gorgeous day. I feel better about myself today than I have felt in some time, and it just feels awesome to be here talking about chemistry with you. And I'm grateful for the wind and the waves and all of the birds in the sky, but I'm particularly grateful for this wonderful day we can share together.
Beautifully said. Couldn't have said it better myself. Thank you so much for being on the show. I have been Wizard.
And I have been Basil.
And please, please, won't you remember that only love will stop the killing.
Only love will stop the killing.
Only
Seul l'amour arrêtera le meurtre.
Only love.
Тільки кохання зупинить вбивство.
Only love.
Only love.
Nur die Liebe wird das Töten beenden.
Only love will stop the killing.
Only love.
Μόνο η αγάπη θα σταματήσει τον πόνο.
Only love. Only love.
Only love.